Alright everybody, time for a new topic and a new video. So we will still be talking about how to find the derivative of a function. Okay? And the derivative means and tells you the same thing no matter what rule or how you find it. But the rule that will be different this time is we'll use something called the chain rule. Okay? And we use the chain rule for a composite function. Now, in the assignment that I'm making and posting this for, there's only one kind of composite function that we'll see, and it will be a function of the form y equals u to the n power, where u is some other function, some formula that involves x, or whatever the variable is, okay? So that would be like this one. See this one? Y equals 1 minus 4x to the 5th power. So notice that that's not like this. Here's something we already know how to find the derivative of. Say you had y equals x to the 5th power, okay? Alright, you know, that's just x. It's x to the 5th power. Now the chain rule will be applicable where that x is some other formula that's more complicated than that, such as 1 minus 4x, alright? Now, okay, so that's the scenario. That's when we use the chain rule. Now, as a disclaimer, there are lots of other times when you'd use the chain rule. There are other functions besides this one where the chain rule is still applicable, and those are composite functions of other kinds, but I wasn't going to complicate that issue because this is the only kind of composite function that we'll see in this assignment. Alright, so if you have a function, y equals u to the n power, then the derivative of that function, y prime or dy over dx, those are equivalent notations. The derivative is n, bring the power down, times u, you know, whatever this u is here, to the power n minus 1, take 1 away from this power, then times du over dx, which is the derivative of this function here with respect to x. If you're more comfortable calling this y prime, or sorry, u prime being the derivative of the u, then you can think about it like that. So n times u to the power n minus 1 times u prime. That's the chain rule. That's how you find the derivative of y is u to the n power. So let's try that on this function. Okay? So I already made the case that it's not that kind right there, in that we would use the chain rule as I've laid it out up here. Alright, we're looking for y prime. So let's just follow through with the rule the way that it is and see what we get. Alright, so y prime is, so let's see, we bring this power down, and then we leave the u as it is. Here u is 1 minus 4x, so that's going to stay. And then we take 1 away from that, so that's going to be 4, 5 minus 1. And then the next thing, the thing that goes right here, is the derivative of 1 minus 4x. Now, you would have to know the rules for finding the derivative of that, but they've already been covered leading up to this point, alright? So if that's something you're not sure about, how to find the derivative of 1 minus 4x, this thing right here, then you'd either go back and review the other material I posted, or ask me or ask somebody about that. But it is negative 4. Okay, that's the derivative of 1 minus 4x. Now, sometimes when we're learning a new rule, I like to label everything. So this is n times u to the power n minus 1. That's this part. And then this part is the du over dx, the derivative of 1 minus 4x. And then we've got the rule complete at that point. From here, all that we would need to do is simplify this. I mean, because we've done what the rule says, so that part's complete, and I guess you could say this is the derivative, but we would like to give our answer to be as simple as it possibly can. So it might be that this can't be simplified. Sometimes there's nothing to do to reduce or cancel or combine the numbers and variables that are there. But this time there is something we can do to reduce this. There's no sense of writing the 5 and the negative 4 separate. This is all multiplication. It says 5 times 1 minus x to the fourth power times negative 4. I can multiply the 5 and the negative 4. And I might as well do that, and that's negative 20. So my final answer will be like this. Negative 20 times 1 minus 4x to the fourth power. I cannot reduce it any more than that. If I could continue to combine things, cancel, whatever it is to reduce it, I would. But here I'm at the end. Okay, so there's our derivative. Now let's look at a few other scenarios where we would apply the same rule. Okay. This is my next problem, and I included this one next because we could use that initial rule, the chain rule, in the form that I gave it. But I guess the difference is that it doesn't seem like something you would use that rule for, because here's my chain rule as I've outlined it. If y is some function u to the power n, then y prime is n u to the n minus 1 power times du over dx, which could otherwise be thought of as u prime, the derivative of this u. But that doesn't look like that. It does not look like something u to some power n. But I could rewrite it, I could re-express it so that it is like that. So let's see. Here's how I would do it. Alright, so let's see. First, roots are convertible to fractional powers. Okay? So with this as square root of 5 minus 2x squared, I could convert that to a fractional power. And then at least I would have a power in the problem, because the setup for our rule reads u to the n power. Okay, so at least I could write it as a power. Here's how we do it. The conversion is, say we got some number n to a fractional power a over b, then that could be converted to the b root of n to the a power. And this is a two-way street. So, you know, I'd say like we're going this way. I've got the root. It's the square or second root of 5 minus 2x squared to the first power. So that's going to say 5 minus 2x squared to the 1/2 power. So square roots convert to the power, the fractional power of 1/2. Okay, so I got 4 over 5 minus 2x squared to the power 1 over 2. Now, that's in this direction, because this rule doesn't say it applies to roots, it says it applies to powers, u to the n power. The next thing is, well, it says it applies to u to the power n, not like 4 divided by u to the power n. So like I need to now not have a fraction, okay? But there's another conversion that we can use. See if you remember this one. The conversion between positive exponents and negative exponents. So I have the freedom to move things either above the bar or below the bar, and all that I have to change as I were to move something is the sign of the exponent. So if this is 1/2, when the thing is under the bar, if I move it up top, it'll be negative 1/2. Now, that's the thing that I can apply the rule to. It says y equals 5 minus 2x squared to the power negative 1/2. That's what I wanted. Now, okay, what about the 4 though? This rule doesn't say you can have a number right there. It doesn't say there can be a 4. So it's like, is that okay? Well, there's a more general rule that would have been discussed earlier with earlier material and videos and assignments. And it says, if you have some constant k, a fixed number, a constant like 4, times some function, then the derivative of that is this number k times the derivative of that function. So in other words, constant factors get carried into the derivative. You don't do anything with them. If I want to find the derivative of this, so if I want to find dy over dx, which is the derivative, same thing as y prime, different symbol, then the 4 just gets carried down, and what I multiply it by is the derivative of 5 minus 2x squared to the negative 1/2 power. Okay, just carry down the 4. You don't do anything with the 4. It's not involved with this rule at all. So okay, I need the derivative is 4 times whatever the derivative of 5 minus 2x squared to the negative 1/2 power. So now I would apply this rule right here. Okay, what does the rule say to do? Bring this power down, so that's a negative 1/2. Then times u, so that's 5 minus 2x squared. Then take away 1, so negative 1/2 minus 1, that's negative 3/2. Okay, and then the last thing that goes here is the du over dx, or u prime, or in this case the derivative of 5 minus 2x squared. But that would be negative 4x. So again, that's by rules already covered, already learned. Review or ask if you're not sure why the derivative of 5 minus 2x squared is negative 4x. Okay, but it is. Okay, now there's my derivative. That right there is the derivative. It's in a way the answer. It's just not as simple as the answer could be. So let's simplify a little bit and we'll take it over here to do that. All right. So to simplify this, I'll try to combine and cancel in any way that I can. And I'm gonna look at it like this. I'm going to kind of divide it up because some of this stuff is above the fraction bar and some of it is below it. Okay, so for example, I've got 4 and negative 4 on top, negative 4x. 4 times negative 4x. I'll get negative 16x above the bar. Below the bar, I've got 2. And then with that exponent being negative, I could correct that and put that down here, 5 minus 2x squared, 3/2 power. Okay. One last thing. I notice up there that I have a 16 over a 2. So I could reduce that to 8 because 16 over 2 is 8. So I'll do negative 8x, right? So now I'm done with the 2. And that'll leave me with 5 minus 2x squared to the power 3/2. And there's my derivative. Okay? Now, that will probably work for MyMathLab, but at different times and different places, you may be expected to know another form of this answer. Okay? So let's do this. Let me tell you, just in case, I think MyMathLab will most likely accept this one, but just in case, here's something that you should know anyway. You may see this expressed as the square root of 5 minus 2x squared to the 3rd power. Okay? Why is that? Well, it's from this, isn't it? So fractional powers can be converted into roots and vice versa, and this is a two-way street. So I have this fractional power 3/2. So 3/2, that would be the second or square root of whatever this thing is to the 3rd power. All right, so it might be like that. I want to make sure that you see this. I'm writing that 3 under the bar or under the root like that. So it may be that way. All right, so I guess if, like I said, I don't think it's likely, but if you got this and MyMathLab rejected it, or then it may be because of this. All right, maybe it says express your answer with a radical or a root, and that would be this form rather than this form. Or if somebody is giving you something, they may give it to you this way. All right, and you would need to know perhaps that it's convertible into this. Okay. Anyway, so that's the chain rule with a few initial examples and a little bit of review in algebra. What we do with fractional exponents, what we do with negative exponents, and there's a lot more from there we could talk about review-wise. So if you're getting stuck, don't forget, ask for help.